Hi. So now let us see how to find the total number of functional dependencies from a relation basing on the given FD section. So actually, how many total possible? Of course, in that trivial FDs will be there, non-trivial FDs will be there. But let us see how to calculate overall actually. So that is also sometimes important. Okay. So here, so the first thing is how many attributes are there in the given R? We have actually attribute A, attribute B, attribute C actually. All possible combinations we must consider. Then we can find the total number of FDs actually. All possible means, so how many subsets are possible? That is what from mathematics we can say. So that is what power set actually. So here, first thing is nothing you selected. So no attribute you selected. So phi closure we are finding. So phi closure is nothing but phi only, right? Okay. Then let us select one attribute individually. So that means A first, A closure. So A closure deriving what? So A is deriving of course A itself, and then B actually. A is deriving B from the first FD. So 1 and 2 if you take. And then by adding B, now B is also deriving C, right? So by using second FD, you can add C also. So this is what entire table it is deriving. So fine, you can close it. Now let us go for the next single attribute, B closer. So in case of B closer, if you observe how many attributes it is deriving. So itself, first of all, and then B is deriving C actually. Yes. Then do you have A in the set? No. So this is what the final B closer set. Go for the C closer same way. Itself C first of all. And C is not exist in the LHS part anywhere. So that is why C is not deriving anything else except itself. So that is what C deriving C only. So this is what single attribute if you select. What if you select two attributes actually? That is what different combinations A, B closer. So in this case, you can see A you can add individually, B itself you can add first of all attributes, and A is deriving B, that is already covered. B is deriving C, so that you can add actually. So that's it. Next combination, for example, A C closer. See, A is there, A part of this entire closure actually. A, whatever deriving, everything definitely will exist. So every time you no need to go here. What A is deriving here, what C is deriving here, you just combine them actually. That is what the automatically the result also. So that is what A deriving A, B, C. That's it. Even if you work from this also, you will get same thing. Is it? So that is what. Now let us see BC closer. In case of BC closer, these two you just combine actually. Even that also you can observe. B you can add individually, C you can add individually. So that itself is deriving actually. So this is what another possibility. And one more thing, that is all three attributes if you select A, B, C closer. Of course, all attributes in the table we selected for closer, and all attributes itself, first of all, they will derive, right? So ABC you can write down. So what is the use of selecting all these things actually? So that is what total number of FDs we have to derive. So that part let us try to understand clearly. So what we are doing is here, for example, ABC, if I take this part, if I take, how many it is deriving actually? So here, whenever you have this many, I can write down. So for better, this let us take because it will take more actually. Understand from this actually. So B is deriving B from the set you can write down, and B is deriving C from this set we can write down, and B deriving together also BC. In this way also we can write down different forms we are writing, and B deriving nothing, 5. So how many possibilities we have actually? 4 possibilities we have. That is nothing but 2 square. So this attribute, B attribute may present in the RHS part, may not present in the RHS part. And C also may present, may not present. So how many attributes are there in the set? So B, C. So B not present, both the attributes not present, this is what. And B only present, this one. And C only present, this one. Both present, this one. So total how many possibilities are there? So number of symbols we used is 2, that is what base power. How many positions? 2 actually, number of positions. Number of positions. So in that way it is 2 square, base is 2, that is 0 or 1, and number of attributes are 2. So like this, here 0 attributes only one possibility, and here 2 power, how many attributes we have? 3 actually, 2 cube. Total FDs are possible 8 actually from this part. Like A deriving A deriving B, A deriving C, A deriving AB, A deriving BC, A deriving AC, and A deriving ABC, and A deriving nothing. That is what total 8. Got it? So this deriving 4, and here you have 1. That means 2 power 1 actually. That is what 2. C deriving nothing, C deriving C. Don't bother about the deriving 5 trivial attributes. We are simply asking total number of FDs actually. So here also 3 attributes. So 2 cube 8 FDs are possible. And here also 8 possible. Here 2 square, 2 attributes are there, 4 possible. And here 3 are there. So here also 8 possible. So total number of attributes, how many possible? Sum of all these things. So that is 1 plus 8 plus 4 plus 2 plus 8 plus 8 plus 4, this one, and this 8. So this total is how much? There are 8, there are 4 8s are there, 8 4s are 32, 32 plus 6, 38, 42 plus 1, 43 FDs are possible actually. So this is what answer for this question. Find the total number of FDs is 43. So in this way, how many attributes are there in the relation? Take the all possible combinations, okay, and find them individually. And like this, how many attributes you are getting in the set? That is what 2 power actually. Number of attributes in the set is in the power, then automatically how many FDs are possible by using that particular closure you will get, and then individually everything is you sum it. That is what overall possible FDs by using this given FD section. If this is changed, then this number is also going to change. That is what you have to inference understanding from this overall discussion. Okay.